Picture this. You walk into work, it's a Monday morning, you log into your dashboard, and bam, you are suddenly handed 10,000 completely unread customer support tickets. Just an endless, anxiety-inducing scroll of unstructured, chaotic text from frustrated users, all screaming for your immediate attention.
Or, hey, maybe you're a data analyst. You've just sat down with your morning coffee, feeling good, only to find yourself staring down a database of 50,000 newly published news articles that just got dumped onto your server overnight. Yikes.
Or, and this is honestly the ultimate headache, imagine an overwhelming flood of 200,000 raw, unlabeled tweets. We're talking dozens of overlapping, trending conversations, complete with slang, typos, and just absolute chaos.
In all of these scenarios, you're facing the exact same data nightmare. You don't have labeled categories. You don't even know how many categories might actually exist hidden in that mess. And let's be real, unless you have a spare decade and a team of 1,000 people, you literally cannot read them all. So how do you instantly extract meaning from this massive mountain of unstructured text?
Well, welcome to this explainer. Today, we're diving into the ultimate, unsupervised solution to this exact problem, topic modeling. We're going to look at the two dominant algorithmic families that have completely revolutionized how we process text at scale, literally turning millions of unread words into crystal clear insights.
Here is how we're going to break it all down. First, we'll outline the core text problem. Then, we'll unpack LDA, which is the classic mixture approach, before exploring BERTopic, the modern cluster. We'll put them head-to-head, evaluate their actual coherence, and finally, give you the ultimate verdict.
All right, let's jump right into Section 1, the text problem. So, what actually is topic modeling? It's basically the mathematical superhero that answers that incredibly difficult "what is this about" question, and it does it completely without human supervision. Imagine taking all of those unread documents and just tossing them into a black box. You feed it a raw corpus, and it hands you back a small, neat set of coherent themes. It automatically groups words like batteries, screen, and charge into a hardware issues bucket, for example. Plus, for every single document, it gives you a clear distribution over those topics. Without needing any prior labels, tags, or weeks of manual reading, these algorithms just scan your data and uncover the hidden structure underneath. It feels like magic, honestly, but it's actually just brilliant linear algebra and probability doing the heavy lifting. Okay, moving on to Section 2. Let's talk about LDA, the classic mixture. Latent Dirichlet Allocation, or LDA for short, has been the reigning champion of this space since 2003. To really wrap your head around LDA, I want you to step away from the math for a second and just think of it like a probabilistic smoothie. LDA's entire generative story assumes that every single document you read is just a unique blend of various ingredients, which are the topics. So a single news article about a tech company's stock isn't just one thing, right? It might be, say, 60% about technology and 40% about economics. In turn, each topic is just a recipe. It's a probability distribution over specific words. The technology topic heavily features words like software or server, while the economics topic leans on words like revenue and growth. To figure this all out, LDA essentially looks at the final smoothies, your documents, and reverse engineers the recipe from the observed words. It outputs two incredibly vital tools, one showing each document's exact mixture of topics and another showing each topic's core vocabulary. Because it relies entirely on counting these raw word frequencies, it's a classic, robust, heavily battle-tested workhorse. Fast forward to 2020. Section 3, BERTopic, the modern cluster.
With BERTopic, we see a completely different, neural-based philosophy emerge. It totally throws out that smoothie recipe concept. Instead, it brilliantly maps documents as physical clusters in a massive embedding space, using a super-modular four-step pipeline. First up, it encodes your documents using a neural sentence transformer. This is like giving the model an actual dictionary, so it truly understands language, turning text into complex 384-dimensional mathematical vectors. But because clustering algorithms tend to completely break down and get confused in high-dimensional math spaces, Step 2 uses a powerful tool called UMAP to compress this down to about 5 dimensions, strictly preserving the relationships between the documents. Step 3 brings in HDBSCN. This is a density-based clustering algorithm that looks for tightly packed, dense areas of documents and groups them together. And what's truly amazing here is that HDBSCN actually flags messy, unclusterable outliers with a -1 label. It literally tells you, hey, I don't know what this is, so random noise doesn't ruin your pristine topics. Finally, Step 4 extracts the defining words of each cluster using class-based TF-IDF. so we humans can actually read and understand what the cluster represents.
All right, Section 4, head-to-head. So, stepping back, how do these two industry heavyweights fundamentally differ? This is where the rubber really meets the road. LDA gives you a granular, mixed membership distribution per document based entirely on word overlap. It totally understands that a long document covers multiple overlapping themes, and it categorizes it based on how often specific words appear. BERTopic, on the other hand, takes a radically different path. It typically assigns a single, highly semantic topic cluster per document. It cares way more about the deep contextual meaning of the sentences rather than just the raw frequency of the words. For example, BERTopic knows that the phrases laggy phone and slow device mean the exact same thing, even though they use completely different vocabulary. LDA might separate those into different topics because the words don't match, but BERTopic groups them together because it groups by human meaning, not just word matching.
Now for Section 5, Evaluating Coherence. Once the math is done and the pipeline finishes, how do we actually know if the topics make any logical sense? Well, we score them mathematically and we score them qualitatively. First, we use something called CV coherence. Don't get bogged down in the complex math here. Just think of this metric as asking a simple question. Do a topic's top words actually appear together out in the real world? If your topic words are steering wheel, brakes, and tires, they probably appear together a lot. Higher coherence means, yes, this is a real pattern. Next, we measure topic diversity. Think about it. If all your different topics share the exact same top words, they aren't very useful for organizing your data, right? Diversity ensures your topics are actually distinct from one another. But ultimately, qualitative inspection is your absolute last line of defense. You just have to read the top words of a topic and ask yourself, does this represent a real logical concept? If a topic's top words are apple, car, and sky, the algorithm failed. Human intuition still reigns supreme here.
Finally, Section 6, the verdict. Consider this your ultimate cheat sheet for your next project. The absolute biggest practical consideration you will face is document length. You've got to leverage BERTopic for short texts like tweets or customer reviews, or when you're integrating with a large language model and maximum semantic meaning is your top priority. But here's the catch. BERT neural network models physically truncate long text. They simply cut it off after a certain number of words. So you should definitely rely on the classic LDA if you are processing massive multi-page documents where you need those nuanced multi-topic distributions. Plus, neural networks are heavy. If you're running on an edge device or a local server with limited computing power and no GPUs, LDA is going to be your best friend.
So what does the modern analytical stack actually look like? Well, it gives you incredible adaptability. Moving forward, BERTopic should absolutely be your default starting point for semantics. But for classic LDA, mature libraries like GenSim and scikit-learn are incredibly battle-tested and ready for enterprise production right out of the box. If you need a blazing fast alternative for short text and want to skip the heavy neural networks altogether, non-negative matrix factorization, or NMF, is fantastic. Dealing with a truly massive dataset, newer, highly optimized tools like FastTopic have you covered. And the ultimate modern workflow that top teams are using right now. Run any of these clustering algorithms to perfectly group your data, and then prompt an LLM to read a sample of that cluster and give it a perfectly human-readable name. It's the absolute best of both worlds. We've explored the classic recipe-style word overlap mixtures of LDA and the deep, context-aware semantic embedding clusters of BERTopic. Armed with this fundamental understanding of probabilistic mixtures versus neural networks, which tool will you choose to finally conquer your mountains of unread text? The power to instantly decode millions of words is completely in your hands. Now you have exactly the knowledge you need to go out there and build your next great data pipeline.